Okay. So we're talking 1-6, and as I said already, order of operations. The reason we have an order of operations is because we want to be consistent. It would be sad if Mr. A taught you one order of operations and then in Algebra 2 or even Geometry they taught you a different order of operations. Or if I said, hey guys, you know what? I want you to do whatever you want. And so that might be cool for you, but then when you give it to me, I'm getting all these answers and they're not the same. And you're trying to explain it, I'm like, you know what? I don't even know what I did, honestly. Well, that doesn't really help. So, order of operations is super important, and some of you already know what we're referring to. PEMDAS. PEMDAS. I'm telling you right now, I asked several people from different states, what do you know, how would you call it? PEMDAS? I just asked, what's that again? PEMDAS, PEMDAS. Okay, I've never heard it, PEMDAS. Never. Sorry, PEMDAS. PEMDAS. It's PEMDAS. Okay, anyway.
We're from the state and we say
California, Colorado, South Carolina. That's across the country right there. Hundreds. Yeah.
He was a driving instructor.
Yeah, no. Hey, I'll give you this though, guys. In China, they don't say that. So. No. Okay. I just, whatever we say, are we in agreement? This is, please excuse my dear Aunt Sally, PEMDAS. We're good on that? We can unite in that way.
PEMDAS.
There are actually not 1, 2, 3, 4, 5, 6 steps. There are not 6 steps to these problems. There's only 4. The first step is parentheses, which I'm going to write down and give you a little more because it does get a little bit tougher. Parentheses, then exponents. That's the second step. The third step is multiplication and division. It's not 2 separate steps, it's actually just 1. And then addition, subtraction would be your 4th step. Okay? Those are your 4 steps. So please, when I write this on the board, either you know it, great, or you don't know it, and now you know it. You need to follow what we put up here because you're going to be required to do that. And you will have to do it this way.
Can I do some red
You may. Okay. Number 1, we're going to call those symbols. So this is new for you guys, of inclusion. As in, we don't usually say it this way. Symbols of inclusion. Or grouping symbols. You can think of grouping symbols. So does anyone know what some of those grouping symbols are? What's the most common? Think of the letter P. Parentheses. So I'm going to draw them out here. So parentheses. Okay? Those are the most common. Any others? Michael? Brackets. So brackets are these guys right here. And I'll put commas in between. Those are brackets. And remember, you have to have pairs on these main ones. Next one. Yes? Yeah, braces. These are like these symbols. Those are braces. You also have those. Are there any other grouping symbols? Yeah, there are actually. Okay. 1, 2, 3. At least 3 more. 3 more. Okay, ready? The next, yep.
Oh, wait.
Yeah, 3.
I thought they were like double. Wait, never mind.
Okay, so those are the first 3. There are 3 more that we're going to really look at. There could be more. Yep.
Is it decimal point?
Not a decimal point. That's part of the number. Okay. A fraction bar is also a grouping. That's not a negative. That's a fraction bar. If you need to write fraction bar, then do that. Yes, ma'am?
I think I know what Murphy's trying to say. I think is a new one like the brackets and the braces like together. Is that a?
Oh, like if you have a bracket and if you have a bracket and parentheses next to each other, those are actually separate grouping symbols. So you'll have parentheses, and then you might have like brackets right here and like over here. But those are separate. Yeah, but that's a good question because you'll see that. Okay, the other one will be, what are these symbols? Absolute value. So you're going to see those again since we talked about them. All right? And then a last, but certainly not least.
The addition symbol.
No. The root symbols. And we're going to deal with square roots, but yeah, you can have cube roots, fourth roots, all that. Okay. Anything that groups work together is a symbol of inclusion. And so these are the main 3. You will see these sporadically in your problems. Okay, the second, so you have to do that first. Whatever's in those symbols of inclusion, you have to do those first. And if you have, for example, all 4 of these, you have to work within the innermost grouping symbol, usually parentheses, then brackets, then braces, then fraction bar. That one's a little confusing for people. We'll work out a problem just a little bit. Oh my. Okay. Second one. This one's nice. Yes. So like what if you have parentheses and then absolute value, fraction bar, square root symbol? We're going to deal with those. Like how do you deal with that? Because you're going to get that. Oh, that's nice. Exponents. Deal with those powers. And today you're going to have positive powers like positive 2, positive 3, positive 4. But you can also have negative. And this is review, guys. This is not, you don't have to write this in your notes unless you really want to. If I have 5 to the negative second, what do you think of? I'm looking for that word. Reciprocal. So what's the reciprocal of 5? 1 and 5 to the second power. Yep. So you can think about what's that reciprocal? That's what it is. And then you're like, well, but what do I do with that? Well, what's 5 squared? 5 squared. So really it's 1/25. Okay, so that's just review of yesterday's lesson. Yep. Okay. Exponents. You're going to be dealing with those. All right, number 3. I said that the third step is multiply or, the word or, divide. And then you have to do it from left to right. Why left to right, Mr. A? Because that's what we decided.
Because that's how we read.
Yeah, that's how we read here. And so we're going to do left to right. But what? Yeah, like Hebrew, that's a right to left. This is Japanese too?
Japanese people read up.
That's how we read.
Yeah, so, but even it's cool because we have this as our standard universal. Like in our world, we do it this way, so everyone's on the same page. So if I'm looking at a math problem from Japan, and I'm looking at the numbers and symbols, they're going to do it the same way we do, which is nice because now we can do the same thing. What did you do? And they say it to me. I have no idea what you said. They point. Gotcha. So now you can get it.
Same language. That'd be a lot easier.
We did for a while, didn't we?
Exactly. So we should have kept it.
That was cool. Think about it. You could speak to anybody, anywhere. But then what happened? It's cool because I teach my son this. Yeah, the thing is, this is really cool. God knew the potential of what humans were capable of. That tower, you need to think they're trying to reach heaven. That's kind of goofy. No, they would have gotten very far because those people were very intelligent. Just think Adam and Eve. They lived for 900 plus years. You think they knew some stuff? So what if you could communicate with everyone, engineers from Japan, China, Africa, Europe, Americas, and you guys can just talk like normal? You think you can get some things done? So what they were doing, though, is they were getting prideful and saying, you know what? We're going to reach heaven. We don't need God. We can actually do it. And so they were going to build it. And out of their pride, God says, you know what? I'm going to scatter the languages. And what's cool about that is this. You know, Japanese and English, they have some similarities of linguistics. And when you study that, if you're ever led to do that, you're going to see they're different. Now, I'm not saying they're the same. They're different. But there are some similarities that we all share when communicating, which is really cool. And that shows that there's a common origin, which people say evolution, right? You started in Africa and then we spread all out. That's one explanation. But there's also another thing. We're really close in our DNA. Like you and I, you know, my skin color is a little darker, right? I think it is. We're very close. That's really the only difference. Do we have the same organs in our body? Mm-hmm. Do we have the same systems that work together? Does our hair do the same thing? Not. Okay. This hair does not just happen. I'm just going to tell you that. It takes time and love and care. And a lot of product. Okay. No, but we have a lot of common characteristics. It's really cool. Anyway, multiply or divide from left to right. Last step, add or subtract from, and then left to right. You guys understand that I am I am Hispanic, and then my wife is Caucasian, and then our sons are a mix, right? They're a mix. And so they have characteristics of both, but thankfully they don't look like, they're half Caucasian, half Hispanic, and they're just like, oh yeah, they're mixed. I mean, you can kind of tell sometimes, but it's really cool. That's just how God made it. Anyway, add or subtract from left to right. Now listen carefully. I said add or subtract. You have to start from the leftmost side, and you have to add or subtract first. If subtraction comes first, what do? Subtract. If addition comes first, add. It doesn't matter which one comes first. You got to do that left to right. That's your last step. Yes, ma'am?
So when you say or, so it can't be both?
You can have both. You can have subtraction, then addition. So you're like, all right, which one do? I got to do the subtraction, and then I got to do the addition in one step. Multiplying and dividing. I have multiply, divide, then multiply. Multiply, divide, multiply. So I got to do multiply, then divide, then multiply, left to right. Do you guys get that? Because you don't do addition first, then subtraction. That's actually one step. And that's why we put it 4 steps. You guys okay with these? Okay. This is what I did to the other class. I'm going to work this problem. This is going to be my 3rd time today working out this problem. Okay, can I show you what I did? This is the problem. It's my problem. Oh my gosh. This is my problem. Sorry, just get a glimpse. This is what I did.
It's not long enough.
This is my this is my 3rd time. Oh, don't worry, you'll see it again.
Tell me that's what we have to do.
Okay, listen carefully. I told the other class, look, Mr. A now is going to now do for the 3rd time the same problem. Do you think I like doing the same thing over and over again?
No.
Oh, maybe I do. But anyway, it is kind of, listen, it is kind of tough. Like having to write the same numbers again. That takes some effort to do. But I want to do it because I want to show you what I expect of you. And you don't have to do it 3 times for every problem, right? You don't have to do it. I don't want you to do that. Just do it once, but please do it right. And I'm going to try to help you out with that. All right. I'm going to write on the top, the beginning of the problem. Go ahead. You're going to write everything I write. Once. Yeah, not many times, so don't feel bad about that. And make sure you write the symbols where they belong. And I'll try to darken some symbols so you know.
Wait, is this the problem you had on your paper?
Yeah, the same problem.
Good thing I memorized the whole entire thing and now I know.
Yes. Oh, wow.
No, I memorized.
Okay, in your book, they're very nice to distinguish decimals and multiplication symbols. What they do is this. Their multiplication symbols are these big darkened dots. So like, I'm trying to make it like they do, and make it very clear it's multiplication, and then that's a decimal on both of those. Okay. -2 times the quantity, -6 minus 5 times the quantity 1.2 plus 2 squared times 3.5 minus 8. That's the problem. Okay, just think about it, guys. If we just said do the problem, there's no order of operations. Some of you might get the same. Oh, we're best buds. We do the same thing. Great. But then everyone else is like, what did you just do? That doesn't make sense. Now we have a rule of the order of operations that we're going to use. So looking at this right here, what's my first step?
Parentheses.
Yeah, symbols of inclusion. So what symbols of inclusion do I have? I have 2 of them.
Parentheses?
I have parentheses and I have brackets. All right, which ones do I do first? What's inside the parentheses? All right, so I'm going to do this, and I need you to do this with me, and then you can do it a little bit differently on your own. I need to do what's in here first, right? Okay, they're the innermost symbols of inclusion. You see the brackets? And then you see the innermost ones are the parentheses. I'm going to do that first. But, as some of you have probably already questioned, what if you have things going on in there? How am I going to handle these 3 things, 3 steps that I'm going to have to take in there? You have to go back into the order of operation. So here, are there any other symbols of inclusion inside the parentheses? Any other symbols of inclusion? No. Are there any exponents?
Yes.
So this is what I'm going to do first. I'm going to deal with that right there, 2 squared. That's my first step. Now, follow as I write. And I'll give you some leeway, but you do need to do this. Negative 2 times negative 6 minus 5 times the quantity, 1.2. And then what is 2 squared? Times 3.5. No, and I'm going to show you where you can do that, like where you could do multiple things at once, but this one really you can't. I'll show you where you can. We'll do an example where you could do many things at once, but not this one.
You could have done plus 1.2 and put it right there. Yeah. And you just thought about it. And that'd be 5.2 times 3.5. No, you would already multiply. Oh, dude. So you could have done 4 times 3.5 without.
Okay, this is what I want you to do. We're still in that parentheses because we're not simplified, so what would I have to do next? So I'm like, are there any other symbols of inclusion? Nope. Are there any other exponents? Nope. Any multiplication or division? Yes. Left to right, I'm going to do multiplication, division. All right, here it is. I'm doing that. So what's 4 times 3.5?
16.
In between, 14. 14. All right, so here, negative 2. Now remember, guys, I did this how many times? How many times am I doing this today?
3.
This is my 3rd time. And by the way, it's really not that hard. You just got to actually just take the time to write it. It's not like you're doing all the math over and over and over. You're just writing it. Okay, what do I have to do next?
Makes a perfect pyramid too.
What do I have to do next?
14.
Now I'm going to add it within those parentheses. So I get negative 2. And then this, parenthesis, 15.2 minus 8. So that's what I did. If you think this is rough, next year in geometry, if you go into it, a lot of you will, in geometry, they're going to make you do this, and then they're going to tell you, they're going to ask for each step, justify it. You're going to have to tell me which property is being used in each step. You have to write words with it. So do we have to do that today?
No.
Be thankful, because you will next year. You will have to show me, what did you do here? What did you do here? Why did you do that? And then all the way down. All right, now, is there anything within those parentheses anymore? No. So we look at the next symbols of inclusion, and we're like, all right, what do I have to do here first? Somebody raise your hand, tell me. Davis?
Negative 5 times 15.
I'm going to multiply. There's technically like subtraction here, multiplication and subtraction. I got to deal with the multiplication. Okay, so I got negative 2 times the quantity, negative 6. What's negative 5 times 15.2? So here's a little help. If you don't know what that is off the top of your head, it's a, yeah. If you don't know what it is off the top of your head, you can just do 15.2 times 5. So what do you get?
76.
76.0. So 76.0. 76. Negative 76 minus 8. Now, do you notice how I called that negative 76? You're like, Mr. A, isn't that minus 76?
And
It's both. It just depends how you want to see it. Okay, I'm going to erase this so it doesn't confuse anyone. That's just my work. You could do that off to the side and then write your answer back in there. But if I'm looking at this, I'm thinking, all right, inside those brackets, what operation is going on? It's your question. Subtraction and or... Wait, there's no plus sign here.
yeah.
Okay, do you guys remember stay, change, opposite? Stay, change, opposite. So can it be negative 6 plus negative 76? And then you can do it again. All right. You know why addition and subtraction are the same step? You can just make all the subtraction into addition. Addition and subtraction are very similar. If not, we can say the same. What is negative 6 plus negative 76? Negative 82, which is just as critical as the actual number. All right. Now what do I do? Subtract or add, however you want to deal with it. All right. What's negative 82 minus 8 or negative 82 plus negative 8?
Negative 9.
I'm going to write over here because I don't have unlimited space. Negative 90. All right. What do I do next?
Multiply.
Yeah, just multiply. Positive or negative? What? 180 is my answer. 180. Yes, I'm not giving you a ton, but I do want to see that. Unless you want me to give you more.
See, no, the only problem is that it takes so much work.
Guys, don't hurt me.
Do you realize
One at a time.
But we'll get it
Yeah.
all in class, so we'll be fine.
Yeah, I was thinking of that because obviously some of you have games and the back to school bash or practice. Yes, I'm trying to help you here, if you let me. Okay, you guys okay with this? Now, can I tell you this right now? I know this is a lot of work. Some of you can do some of the steps in your head, but if you're going to try to convince me that you could do this whole thing in your head,
Yes.
you are not being, first of all, humble, and then you're not being honest, because there's no way it's happening. And you're like, okay. Okay, how about this? How about this? Let me give you a problem you can do in your head. I'll give you a day to do it in your head.
Can we at least look at it?
You cannot see the answer.
Oh.
Yeah,
No,
so,
I meant look at the problem.
yeah. Ready? Example number 2.
2.
Don't look at that answer because you just saw it. See?
Where did I see it?
We're all going to do example number 2. It's off on page 13. Example 2 in that box. Don't look at that answer. Oh, I got it, Mr. A.
Wait, which one?
Okay.
We do it in our head?
No, those who want to do it in your head can do it. I'll give you a day.
Oh, it shows us our second.
Just
No, it shows us our.
Oh my god.
The answer's 2.
That is amazing. No way. No way. Okay, stay with me here, 8th grade. Stay with me, 8th grade. They could, I guess they could spend their time doing that. But I want to say this. They're going to spend that day doing it, and they might get it. Yes. And then you're going to do it in about 2 minutes.
Ooh, God.
Right?
Got the answer. Yeah.
So show me your work. Yeah, I know it's
Oh, we
amazing.
can't because it's not mine. Yeah.
No, sorry, everyone else. I can't believe I got it, Mr. AC. Okay, we're done. Everyone else, we're going to write that problem up on the board. We're going to work it out. And we're going to find out, although it looks really complicated, it's really not that bad. Okay, so write it down, please. And though, I mean, it gets tougher too, so these aren't the most difficult, but if we can do these, you should be well set. That's amazing. They got it. Okay, this is the problem we're doing. Yeah, if you could do it mentally, that means quietly. That'd be helpful.
Sorry, I didn't know
That's
there was a
okay.
second bar.
Yeah, that's gonna be a bummer. Yeah, this is the problem. So this is your problem. I'm just copying it.
Oh my goodness.
Yeah, we're gonna do it together with work, and then we'll give them their time to do their mental work. We do. I want to give it.
I'm not going to get it until like 8 o'clock.
I know, but I'm waiting for you guys. Yeah, I mean, I think like a huge majority have something to do tonight, and so I want to help you out, and you will have time if you stay with me. So let's keep going here. Okay, here, how many symbols of inclusion do I have? I have parentheses, many of them, right? And I have many, or a couple, brackets. But I also have another symbol of inclusion, which is the fraction bar. So this whole thing is wrapped around a symbol of inclusion, and so is this whole thing, which you can kind of see with the brackets anyway. So there are a couple ways to work it out, but this is how we'll do it. Okay, looking at the numerator here, are there any other symbols of inclusion other than the fraction bar? Other than the fraction bar? Yeah, write it out because we're going to do it. Yeah. Yeah, good.
We beat you too.
Yeah, you did.
Yeah.
As I was sitting here.
Mr. Right, no excuses.
You record time, 6 minutes. Nice. Okay, here, what we're going to do is we're going to deal with the innermost parentheses. So we can do all of these at once. Do all of those at once because we're dealing with all the parentheses. So that's good. Okay, So what is 3.2 plus 4.8?
8.
All right, I'm going to write over here. It's 8, and then it's still squared, plus, what's 5 plus 1? 6, and then we're going to square that, and then plus 30. So all I did was I got rid of those parentheses, so I'm good with that. Okay, and then on the bottom, what's 7 minus 4? Yes, 3 to the 4th. And then what's 8.5 minus 6.5? 2. All right, so this is what we have. Okay, so you did that all on the first step, which is nice. You didn't have to do it like one each time. Just do them all at once. And the second step, so this was your first step. The second step, all right, all the parentheses are simplified. So now what do I deal with? The exponents. Good. Is that what you're going to say, Peter? Good. Yes, sir. Okay. Do you need... Can you finish this problem, and then when everyone's working, I'll let you go? Yeah. Just so you can get this, because I don't want you to miss. Okay. Yeah, I'll definitely let you go. Okay. What's 8 squared? 64. What's 6 squared? 36. Plus 30. And it's still over. All right. What's 3 to the 4th? 3 times 3 times 3 times 3. 81. Sorry, I'm going to make that clear. That's not good. And then what's 2 to the 4th?
16.
Good, 16. All right, so you just did your second step. Now, does this problem look that difficult from here?
No.
Sorry, Nick. It's kind of as far as I can go. Okay, then what I'm going to do is I'm going to deal with those two. What's 64 plus 36? And I'm going to do the next step up here. 100 plus 30. And then over, what's 81 minus 16?
65.
65. Okay? What would I do next?
Add the 130.
Okay, add these two together. And I got my 130 over 65. Oh, equals 2.
I'm pretty sure we got it faster than you, Mr. Ray. Yeah. So now
You guys actually do it in your head?
Yeah.
John did. I covered it all up with pens and he did. Yeah, but here you saw the answers.
No, I didn't.
Yeah, here you saw the answers.
I did. I promise you I didn't.
That doesn't count.
Because if I gave you like number 6, that would determine if you really knew.
I can do it. Okay, let's do it.
No, you two will do it, and I'll give them their homework. Since you do it so fast, you don't need that much time, right?
Yep.
It's up to you. Okay. Listen carefully. I do need to see work. Now, you don't have to write the original problem up there because it's already in your book. So when I'm looking at this problem, I can underline in my book, and then I can just write this down as my first step, right? Then do that one, that one, that one. Okay, just show me your work. Sorry? Oh yeah, write the problem if you need it, but you don't have to. And you only have, what is it, 2 through, it's, okay, let me give you the homework. It's 2 to 20 even. 10 problems, yeah, 10 problems. So if you have a lot to do, it would not be wise to goof off and waste the rest of your time and then, Mr. Ray, I have a ton to do, but yeah, I gave you time to work.
Is it 30 over negative?
Oh my god.
I don't know.
12?
I'll look at it in just a moment, sorry.
Oh.
Wait, what? Wait, which one?
No.
30 over negative 12? No! I was trying to get it.
You could do that. That's totally your right.
No, we did not.